anybody see that stubby antenna at a mile? So I'm really not a big aftermarket antenna guy. You know, for the most part, I am tried and true to Motorola in most circumstances. But there are times when the flexibility of a ham-targeted radio and some of the features they possess outshine some of the Moto gear. But you don't have to look too far to find a lot of people out there saying the first thing you should do with your radio is throw the antenna that came with it right in the trash. And today, we're going to put some of that to the test. Now, here's the thing. When it comes to antennas, there's always three things that you're competing for: size, efficiency, and gain and bandwidth. It's always a triangle. You can have two of these things, but you can never have all three. So if you wanted that small antenna, you're going to be more limited on your bandwidth. You're going to have less bands to work with, and you're going to have less efficiency and less gain. If you want more gain and more bandwidth, then you're going to have to deal with a larger antenna. Your rubber duck antennas that usually come like stock on your HTs are anywhere between like 4 inches and 8 inches. Then you could go up to like a whip style antenna, like a signal stick, and they can get up to almost like 19 inches. And they're usually just a single strand of wire, and they're opposed to a helical coil that makes up that entire element. There's also the telescoping antennas. These are stainless steel elements that can be compressed for storage, and they can get out to 5/8 wave. But the problem with this is that these are extremely fragile just by their nature of design. In addition to these mechanical designs, there's also the factor of electrical designs that have to be brought into consideration. So you have your quarter wave vertical, and this is obviously one of the most common designs and really should be what you're looking for to achieve and to get as an acceptable level of efficiency out of your HTs. Now, even with this more or less appropriately matched, you're going to have a compromised ground plane with an HT. If you have a half wave antenna, these are fed at a voltage maximum and a current minimum, and as a result, half a wavelength antenna would be absolutely awesome on an HT. But now we're coming back into that whole size issue thing we talked about with our whole triangle of factors. The third thing you got to look at is your electrical design of an antenna. This would have to be 5/8 wave. This gives you pretty good omnidirectional gain, but now you have an even larger size trade-off and the need for a better ground plane. So these really, wouldn't perform quite as well as you would think they should because the ground plane issue of the HT radio. And speaking of the whole electrical issues, and speaking of the ground planes, on an HT, the ground plane is compromised of the chassis of the radio, which is really just a small chunk of metal. So what happens is that you as the operator actually become part of the ground plane. When your hand is holding the radio, the capacitive coupling between you and the radio turns you into part of that ground plane, which really helps the radio perform better. Now, with all of this, of course, there are things that we could do to really help increase our distance. Things like, number one, being a counterpoise you could incorporate into that, which really does a great job of increasing your ground plane. But this now has us having a dangling wire coming off of our belt or plate carrier or chest harness. And I don't know about you, but I'm not really in favor of putting one more thing to just hang off me that can get snagged or ripped off. We just put the receiver in place. It's right at about 3 feet off the ground. I figure like if a person was wearing it on their waist, it's kind of perfect for that. What we're going to do is do a comms check at every quarter mile. So everything has been GPS'd out. I know exactly where to go. We're tracking everything along. We'll do it at a quarter mile, a half mile, 3/4 of a mile, and then the final test will be done at 1 mile. And here's a quick look at the terrain profile, the topography maps, and also what we call a shaded relief map. So you can kind of see the terrain this is going through and the terrain profile of what these radio waves are going to have to get through, and we'll see how the antennas do. All right, so at our first checkpoint, this is a 1/4 mile away. We're going to start off with just the OEM antenna that came with the Alliance HD1. We're doing this testing on a UHF frequency just because through all of our testing, we've had the best success with UHF. So UHF analog, let's see what happens.
Testing on UHF analog, 1/4 mile out on the standard antenna. Testing 1, 2, 3, 4, 5. OEM Alliance HD1 antenna, 1/4 mile out. Testing 1, 2, 3, 4, 5.
So the next we're going to test is the Nagoya NA701C. Now, no one recommended this antenna to me, but I just feel like Nagoya is just a staple in the ham community. So I wanted to include it in this test. And this is a dual band VHF, UHF, whip style antenna. Now, this thing is advertised to provide a notable performance boost with up to 2.15 dBi gain, specifically tuned to higher frequencies, mainly used by guys who have used it for VHF in the MERS band, commercial guys, or even government users. And it says that it endures the outdoor conditions better than your OEM antennas. And it also claims that the antenna will to ensure continuous connectivity and significant improvement in reception quality. They go on to further say that they individually test and fine-tune each antenna, and they believe that gives them an unmatched performance in their product. And since I just mentioned the gain of an antenna, if you aren't familiar with what antenna gain is, this just serves as an indicator of the signal strength that an antenna can either transmit or receive within a set direction. And the calculation of gain involves a comparison between the actual power transmitted or received by the antenna in a particular direction with the power that an ideal antenna would transmit or receive in the same scenario. I will say, feeling this has a great build quality, and it definitely seems rugged enough. And I think a very interesting part of this is the fact that Nagoya partnered with BTEC, and I know they are very popular with a lot of people. So if you order a radio through BTEC, they are guaranteeing that you are getting a US-made, genuine Nagoya antenna, and you're avoiding running into possibly getting a knockoff like off of Amazon. So with all of that said, let's see how the Nagoya 701C does. Testing the Nagoya 701C.
1/4 mile out. UHF analog. Testing 1, 2, and 3, 4, 5. Testing UHF, the Nagoya 701C. 1/4 mile out. UHF analog. Testing 1, 2, 3, 4, 5.
Now, next up, we have the signal stick antenna from Signal Stuff. This one I heard a ton about from the comment section from all of you guys, and some of you are obviously signal stick fanatics, so I had to get one to try it myself. This is another handmade antenna. It's actually made in Utah, and these are specifically target for amateur radio enthusiasts, and they say that, those that are seeking performance and durability. These are definitely ultra lightweight and nearly indestructible. As you will see, most people store these things in a configuration where they twist it, and then they tuck it back in, and they work out just fine. Signal Stuff claims that these antennas will outperform the stock antenna or your OEM antenna that your radio came with by a significant margin. Now, what's really cool about these antennas is the fact that they were originally designed as a fundraiser for youth group sales, and now these antennas are providing funding for ham study, exam tools, and other initiatives that support the amateur radio community. So I think that was awesome to hear. Now, this thing being a dual band version is a 1/4 wave on 2 meters and 3/4 wave on 70 centimeters. So let's see how this does at our receiver. Again, 1/4 mile out, we'll see what happens. Testing the signal stick.
1/4 mile out.
On UHF
analog. Testing 1, 2, 3, 4, 5.
1/4 mile out.
1/4 mile out
on the
signal stick. Testing 1, 2, 3, 4, 5.
Now, the next few that I'm going to be testing out, these would be the most highly recommended ones by all of you in the comments. And these are the Smiley antennas. Every single test that I did, and I put a video on it, people are always like, you need to check out Smiley antennas. So that's what we're doing. I bought 3 different ones. We're going to give them all a try. So Smiley Antennas, this company has been around for a long time, which I didn't realize. They've been around for like 40 years. And it was started by two guys, Bill Smashy and Don Smiley. And this is another U.S. company. These guys are actually based out of San Diego. Now, Smiley Antennas says that their antennas are built on a foundation of special steel coils, which are crafted exclusively for Smiley antenna, and that these coils undergo meticulous copper plating, and that process to ensure optimal power transmission. So we're going to give each one of these a shot, and we'll see how they do. Okay, so our first one coming out of the package, this is the 5/8 slim duck antenna.
Testing UHF analog, quarter mile out on the Smiley 5/8 slim duck antenna. Testing 1, 2, 3, 4, 5. UHF analog, quarter mile out on the 5/8 slim duck antenna from Smiley. Testing 1, 2, 3, 4, 5.
All right, the next one we're going to do this is the slimline antenna from Smiley. We'll see how this one does. Testing the slimline antenna
from Smiley. Testing 1, 2, 3, 4, 5. UHF analog, quarter mile out. Testing 1, 2, 3, 4, 5. On the slim line, quarter mile out. UHF analog. Testing 1, 2, 3, 4, 5.
All right, and then we got one more. The last one I kind of got, not as a joke, but it's a stubby antenna. But again, it's from Smiley, so I figured I would just see how it did while we were out here, see how far we can stretch it out to, and who knows how it'll do compared to the OEM antenna. Okay, so here this guy is. Put this on. Testing the
Smiley stubby antenna. Testing 1, 2, 3, 4, 5. UHF analog, quarter mile out on the Smiley stubby. Testing 1, 2, 3, 4, 5.
Okay, well with that done, let's push this out to half a mile and see what happens. All right, we made it to the half mile point. We have our OEM antenna back on here. Let's give this a shot. Testing on the
OEM antenna. Half mile range. UHF analog. Testing 1, 2, 3, 4, 5. Half mile range. UHF analog on the OEM antenna. Testing 1, 2, 3, 4, 5.
All right, right from here, we're going to go back to that Nagoya 701C. All right, so got this Nagoya back on here. Let's see how we do. Testing on the Nagoya.
Testing on the Nagoya. Half mile range. UHF analog. Testing 1, 2, 3, 4, 5. Half mile range. On the Nagoya. UHF analog. Testing 1, 2, 3, 4, 5.
All right, let's see what the next is the signal stick antenna. Here we go. Testing on the
signal stick antenna. Half mile range. UHF analog. Testing 1, 2, 3, 4, 5. On the signal stick. On UHF analog. The half mile mark. Testing 1, 2, 3, 4, 5.
Okay, now we have those three Smiley antennas. Let's see how they do. We're going to start with the slimline. Testing
on the Smiley slimline antenna. Testing 1, 2, 3, 4, 5. Half mile range on the Smile. Half mile. Testing 1, 2, 3, 4, 5.
Right from there, we're going to go with the 5/8 wave. I'm sorry, the 5/8 slim duck. We're going to go to the 5/8 slim duck antenna. Testing on the 5/8 slim duck antenna.
Testing on the 5/8 slim duck antenna. UHF analog, half mile range. Testing 1, 2, 3, 4, 5.
5/8 slim duck Smiley antenna.
5/8 slim duck Smiley antenna. Half mile range. Testing 1, 2, 3, 4, 5.
Okay, and then last but not least, we'll go ahead and put this stubby on, and we'll see how that does. Testing on the Smiley stubby.
Testing on the Smiley stubby. Half mile range. Testing 1, 2, 3, 4, 5. Half mile range. Smiley stubby. Testing 1, 2, 3, 4, 5.
Okay, see it 3/4 of a mile. Okay, right there is the 3/4 of a mile mark. Let's get that standard antenna out, give this a try, and we'll see what happens. Okay, here's the Alliance HD1 OEM antenna. Testing 3/4 of a mile.
Testing 3/4 of a mile. UHF analog on the Alliance HD1 OEM antenna. Testing 1, 2, 3, 4, 5. 3/4 of a mile on the OEM antenna. Testing 1, 2, 3, 4, 5.
Okay, next up we'll put that Nagoya on, see how that does. Okay, so here's the Nagoya. Testing.
Testing 3/4 of a mile range. UHF analog on the Nagoya. Testing 1, 2, 3, 4, 5. 3/4 of a mile on the Nagoya. Testing 1, 2, 3, 4, 5 on UHF analog.
Okay, after that we'll do the signal stick from Signal Stuff.
Testing the signal stick. 3/4 of a mile range. Testing 1, 2, 3, 4, 5. UHF analog. 3/4 of a mile range. Testing 1, 2, 3, 4, 5 on the signal stick.
Okay, now we'll go into all of the different Smiley antennas. Okay, first Smiley antenna is going to be the Slimline.
Testing the Smiley Slimline. Testing 1, 2, 3, 4, 5. 3/4 of a mile. Testing 1, 2, 3, 4, 5 on the Smiley Slimline. 3/4 of a mile. UHF analog. Testing 1, 2, 3, 4, 5.
Okay, after that we got the Smiley 5/8 antenna.
Testing the Smiley 5/8. 3/4 of a mile. UHF analog. Testing 1, 2, 3, 4, 5. 3/4 of a mile on the Smiley 5/8 antenna. Testing 1, 2, 3, 4, 5.
And last, we'll give that stubby a try, see what happens.
Testing the Smiley Stubby. 3/4 of a mile. UHF analog. Testing 1, 2, 3, 4, 5. UHF, the Smiley Stubby. 3/4 of a mile. Testing 1, 2, 3, 4, 5.
Okay, we'll push this out to our mile mark. We'll try everything again, and we'll see what happens. Okay, so there we are, 1 mile. First up, the OEM antenna on the Alliance HD1.
Testing 1 mile. UHF analog. OEM antenna. Testing 1, 2, 3, 4, 5. UHF analog on the OEM antenna. Testing 1, 2, 3, 4, 5 from 1 mile.
All right, after that, we're going to go back to the Nagoya, see how this does. Testing 1 mile.
Testing 1 mile. UHF analog on the Nagoya. Testing 1, 2, 3, 4, 5. 1 mile out on the Nagoya. Testing 1, 2, 3, 4, 5.
Right from there, we'll go to the signal stick. And guys, I got to say, if you're swapping antennas out and you're not using BNC connectors, it's amazing how fast and efficient that really is to do that. Testing on the signal
stick.
1 mile out.
1 mile out. Testing 1, 2, 3, 4, 5.
UHF analog.
UHF analog 1 mile out on the signal stick. Testing 1, 2, 3, 4, 5.
And then right from here, we'll go into the Smiley antennas. So this is going to be the Slimline. Testing Smiley Slimline. 1 mile out. Testing 1, 2, 3, 4, 5. Smiley Slimline.
Smiley Slimline. Testing 1, 2, 3, 4, 5. 1 mile out.
All right, now we'll do their 5/8 antenna. Testing the Smiley
5/8 antenna. Testing 1, 2, 3, 4, 5.
1 mile out.
1 mile out on the Smiley 5/8 antenna. Testing 1, 2, 3, 4, 5.
And then right from there, we'll keep our expectations nice and low, but we'll go ahead with the stubby antenna and see what it does. Testing the Smiley Stubby.
1 mile out. Testing 1, 2, 3, 4, 5.
Testing with the Smiley
Stubby antenna. 1 mile out. Testing 1, 2, 3, 4, 5.
Okay, let's get all the way back to the receiver, pick that up, and then we'll listen to the results and see what we got. Okay, so there are the results of the test. And I have to say, I am genuinely shocked as in a whole how well all the antennas did. I don't know if this is a difference in the type of trees that are here in Alaska compared to back in Maryland. The density is the same. These are very dense woods. It's also very dense back in Maryland, but I am shocked that at the 1 mile mark, all of the antennas got through there as well as they did. It also could just be the differences in terrain, but I shared the terrain profile with this one as well. And it's kind of similar as far as like, you know, a steep slope and coming back up in elevation. So that was very similar. I'm just, again, really impressed with how well they performed here. It also may be just due to the fact of just general RF interference and the fact that it's so unpopulated here that there's just not as much for the radio waves to kind of get lost into. So that was really cool to see. I have to say, all of these antennas performed very well. The Smiley antennas, for all of them being significantly smaller than the OEM antennas as well as the Nagoya and the Signal Stick, man, those things blew me away on how well they really did. And I have to say, did anybody see that stubby antenna at a mile out performing that well? I was just blown away by it. I have to say, this to me, man, I think I am a Smiley antenna fan. The results were just, they spoke for themselves. I hope you guys enjoyed this test. I hope the audio came through as well as I think that it did. Thought this was really good to do. We're going to continue the testing, but I think I may be a Smiley fan for sure, and may go about putting those on a lot of my radios. I like how flexible they are. I like how small they are. And I like how well they perform. That was just incredible to see. I hope you enjoyed this testing. We still want to do more. Endured the bugs, endured all the terrain, had a good time. So we'll see you on the next one. And with that, be safe.